Hello, and welcome to today's webinar, the State of 911 webinar series, hosted by the National 911 Program. My name is Sheila, and I will be the moderator for today's session. This webinar series is designed to provide useful information for the 911 stakeholder community about federal and state participation in the planning, design, and implementation of next-generation 911 systems. It includes real experiences from leaders overseeing these transitions throughout the country. Today's session will feature presenters from the Office of the Chief Information Officer of the United States Department of Transportation in Fairfax County, Virginia, Mr. Steve Lewis, Chief Geospatial Information Officer, and Mr. Thomas Conry and Ms. Judy Dildora, Fairfax County GIS Department, will discuss two different GIS projects. For information on future National 911 Program webinars, to access archived recordings, or to learn more about the National 911 Program, please visit 911.gov. Feedback or questions about the webinars can be sent to National 911 Team at mcp911.com. If you are experiencing difficulty with the WebEx application, please call WebEx Technical Assistance at 1-866-229-3239 and select option 1. Please note that all participants' phone lines have been put in a listen-only mode, and this webinar is being recorded. To ask questions of our presenters, feel free to take one of two actions. Use WebEx's chat feature located on the right-hand side of your screen. Enter your question at any time during the presentation, and it will be entered into the queue. This feature is not visible while your screen is in the expanded page view. Or to ask your question live, use the raise hand feature to request your phone line to be unmuted, and you will be called upon to ask your question. With that, I would like to introduce Ms. Lori Flaherty, Coordinator for the National 911 Program. Lori, please go ahead.
Thanks, Sheila. This is sort of GIS Day today on this webinar, and we're fortunate to have two groups of folks with us who have been doing an awful lot in that realm. The first person who will be presenting is Mr. Steve Lewis. Steve, as Sheila mentioned, is with the CIO's office here at the Department of Transportation. He is the Chief Geospatial Information Officer, and he will be sharing information on the DOT's efforts to create a national address database and the National Address Database Summit. Steve, the floor is yours. Thank you.
Thank you. Okay, DOT has not been involved in the address game for too long, but we finally realized that with Lori's efforts at NHTSA behind the Next Generation 911 program, and also our efforts at Federal Highway Administration, where we are collecting from each state a complete highway network, and addresses are tied to highway networks, we thought that it was time for us to take some action and try to get some movement going towards building a national address database. I'd like to start the presentation with our vision, and as you can see from the source statement, this came from a report from the National Geospatial Advisory Committee that dates all the way back to 2012. And that's been almost 4 years ago now, but there's been a call for a national address database, authoritative, publicly available, for many more years than that. This was just a call to action from the National Geospatial Advisory Committee. Next, please. So that was the vision. This is our mandate. A few years later, 3 years later, from that NGAC report, the GAO published a less than flattering report about geospatial data. And one of the recommendations from that report was to create an address theme under the National Spatial Data Infrastructure with the associated subcommittees and working groups to make sure that an address database is built. The Federal Geographic Data Committee steering committee was named as the responsible party by GAO for that recommendation, but DOT and our partners at the Census Bureau have taken the lead on the National Address Database. Next, please. So to start things off, we decided to hold what we called the National Address Database Summit. It was held last April in near BWI Airport, Maryland. It was funded by DOT, and our objective was to figure out just how we could build an ad. We had broad stakeholder representation. But we had the government, federal, state, local, tribal. We had private sector. We had nonprofits and trade organizations for a total of not quite 100 people. And we did bias the attendance towards state, local, and tribal governments that have existing address programs and can tell us the best way forward. Next, please. This is the model that came out of that two-day summit. It's pretty simple, but it makes good sense. You can see in this simple chart here that the local government is the authority for address data. So they should remain the authority, and their data flows up to the state government. The state government acts as an aggregator of the data, and then the state data feeds into the federal or national address database. We think that there is an opportunity, and this came from the summit as well, for what we call vetted crowdsourcing, where we could get some crowdsourced data and use as quality control and feedback for the local authorities. And we also see a national level geocoder running off the eventual national address database. Next, please. So one of the strong recommendations from that summit was to keep building on the momentum we had there and to conduct a pilot to keep this process going. So we kicked off a pilot in October of last year. The first thing we did was put together an advisory group for the pilot that was, again, comprised of state and local government leaders for address data, so to make sure that this didn't become a federal project, but remained a national project with much input from the authoritative source. DOT, again, funded the pilot and had a few goals. First, we wanted to determine a minimum content guideline for a national database. We wanted to look at existing workflows and understand best practices for rolling up addresses. We wanted to look at the technical feasibility of going from so many different databases into a national database. And first and foremost, we wanted to keep the national address database open and in the public domain. Next, please. So the pilot's wrapping up now. These are the results we have in brief. We basically broke the address universe into haves and have-nots. The haves, are, of course, are those that have existing and mature address programs, and the have-nots are entities that do not have programs but will need them to meet next generation 911 requirements. We also did extensive outreach to the Gila River Indian community and the Navajo Addressing Department and our authority and the Department of Navy, who has just finished collecting addresses, because the idea is that we want all addresses to be available in an ad. We took a look at some existing systems, namely OpenAddresses.io and Community Tiger, which are Open Addresses as a grassroots effort to build a national address database, and Community Tiger is the Census Bureau's online tools for communities to use to build an address database. We identified a minimum content guideline, and I'll talk a little bit more about that in just a few minutes. And we did schema comparisons. First off, there are two recognized schemas for collecting address data, one developed by the Federal Geographic Data Committee, and the other, I believe, endorsed by NINA, which is the CLDXF standard. We found that virtually no one is using one of those schemas in its entirety. All the states that we studied, and you see those there, in the next sub-bullet. All of them were using a mixture of FGDC and CLDXF elements. We also looked for the have-not side of the equation. We looked at best geocoding and address list data sources to build seed data for a community that could later be verified as authoritative. I also want to mention on this slide that with the money we had for this pilot, we decided that we could take deep dives into 2 states. And Arizona and Arkansas were the first 2 states to jump forward and volunteer. So those are the states that we did the deep dives in. And as you'll see in a little bit, they are the first 2 states in the pilot national address database. Next, please. This is a very general look at the minimum content guideline that we developed through the pilot. The first component there on the left is the address itself, and the address follows both FGDC and CLDXF standard for the address, full parsing. The sub-addressing portion, as I'll show in another slide, that is pure CLDXF. The component in the middle there is the geographic location. So that's the most important part of this work. We have the longitude and latitude, and for our friends at the Federal Emergency Management Agency, we have the national grid coordinates. On the right there is what I consider to be one of the most important parts, and that is metadata about the address, including the authority, the source, the type, and even the placement, such as rooftop or driveway. Next, please. So from that general schema, we developed a real schema, and this is not the best of screenshots, but this is a look at the schema that we developed. In the light blue at the top are the FGDC CLDXF address components, and again, the address itself follows FGDC and CLDX standards. They're identical for the address itself, and then for the sub-address, it follows the CLDXF. The purple is the location, the longitude and latitude, and the national grid coordinate, and the green is the metadata. Next, please. So we took the data from Arkansas and Arizona, and using the new schema that we developed, we built ETLs, or extract, transfer, load routines, and we took the Arkansas and Arizona data and transformed it into our new minimum content schema. You'll also noticed a little to the north of Arkansas and Missouri, we had one county in Missouri that was so in favor of what we were doing, they volunteered to give us their data, and we also ETL'd their data into our version 1 national address database. Next, please. So that was the haves that we studied. I want to talk a little bit about have-not entities. So our goal was to find agencies, most likely tribes or counties, that haven't created a address database yet, but they want to. They're interested and motivated, and they want to work with us. So we did a little bit of exploration and ended up with Jackson County, Arkansas. The GIO there in Arkansas was very helpful in helping us find a partner, and Jackson County is who we ended up working with for have-nots. Next, please. So Jackson County had a wide array of data sources for addresses, but did not have that longitude and latitude component just yet. They provided us with the county-wide E911 address list, and that was 18,000 records. Some missing zip codes, but and it needed a little bit of scrubbing, but for the most part, it was good data. They also provided us county-wide road center lines, and it was very good data. It was ready to go. They provided us a county-wide parcel set that where 79% of the parcels had some of the addresses in there, and we did have to do some standardization to make it ready for geocoding. Next, please. We also went out and purchased for this pilot Melissa data. And if you're not familiar with Melissa data, it's just one of the many commercial providers of geocoding data. And the reason we chose them is from our research, they were one of the few data providers that laid claim to their longitude and latitude falling on the rooftop. So we used Melissa data to geocode for a first round. We then used the county parcels for another round. We used the county road center lines for a third round, and we followed it up with a fourth round using census road center lines. So if an address wasn't matched in one source, the next source was used, and we did do a hierarchical approach starting with the Melissa data. When all was said and done, we achieved a 77% overall match rate from the 18,469 records. That might not seem like the best in the world, but that's 77% of the records that now have longitude and latitude, and they can be verified by the county. Next, please. This table shows the match rate for each of the geocoding sources. The Melissa data that we went through first got the highest match rate at 38%. Parcel centroids gave us another 9%. The very good county road center lines gave us another 23%, and the census gave us 7%. Next, please. So this gray area here is Jackson County with the geocoded points now displayed. The orange points predominantly there, those are the Melissa data, and you can see the others as well. Next, please. So preliminary findings from our pilot. Tribal participation is going to be a challenge. We've done lots of outreach, but no data was explicitly contributed from the tribal governments that we spoke with. As it turns out, the Gila River tribal data we did get, but it was part of the Arizona statewide submission. It wasn't submitted separately. Data sharing agreements to make this data open and in the public domain, that could be a challenge. Arizona had some rules in place where they did not share their address data. We got it as part of the pilot with the agreement that we wouldn't distribute it. Arizona since then has been working very diligently to get the county governments to change their mind. And as of now, almost all of the counties have decided that they will allow their data to be part of the open and public NAD. Aggregating existing data aggregating existing statewide data from the HAB entities was very straightforward. The ETL process for Arizona, Arkansas, and the one county in Missouri was very easy. And we now have 5 additional states that have volunteered to develop their own ETLs so that their data can be included in the pilot data set. The schema is going to evolve. So we're not calling it a standard right now. It's a minimum content guideline with associated schema, but we needed something to get started, and we think this is a good starting point. Next, please. So what's next? As I said, the pilot is officially over. It ended in July 31st. We don't have the final report yet. That will soon be coming. But what we want to do is make the database with the pilot Arizona, Arkansas, and Boone County, Missouri available for everybody to take a shot at. And also those 5 states that are developing their own ETLs, we're going to include those in the first public release of the data set. So development comes next. We have to choose a platform. I'd like to keep this open, so we're looking at PostGIS, which is the open source database for GIS, and we're looking at a development environment here at DOT and an Azure cloud instance that we have. And when we get to production for distribution of the data, the federal government-wide geospatial platform will be the production site for the National Address Database. We are working with the 5 states that have volunteered to develop their own ETLs at no cost, and we are actively recruiting other states to also to do that for us. And that leads to the next bullet, which is identify funding to launch. We're looking for these state volunteers because as of now, my dollars have run out. And who knows what will come with the next fiscal year, but the funding is gone for this fiscal year. And the last thing I want to talk about is a data challenge that could help the have-not entities. Next, please. So we're going to launch a data challenge under the America Competes Act, and the goal is to develop a crowdsourced application that can gather address information in the minimum content guideline that we developed as part of the pilot. The idea is that the app can be used by local police and firemen, by real estate agents, by Boy Scouts, Girl Scouts, or by the U.S. government's FEMA Corps, or just by the general public. You press a button and generate a longitude and latitude and a national grid coordinate for a location. So the results of this would be by no means be authoritative, and it would not go into the official national address database. But we think that the results from this crowdsourced app can be used as seed data for local governments that they can take and verify by any means they see fit. And once they have verified the data, made it authoritative, it can feed into the national address database. We also think that the results from this app can be used as just another source of quality control for existing address programs. Next, please. For more information, we have a couple of Google sites here. The first one contains all of the information that was gathered from the summit that was held last April. And the second site there has all the information, including the schema that we developed for the National Address Database pilot. Next, please. That's what I have for you today, and I'm now happy to take any questions.
Thank you, Mr. Lewis. We'll start the Q&A portion of our session. As a reminder, to ask a question, please use the WebEx chat feature located on the right-hand side of your screen, or press the raise hand button so we can unmute your phone line. Our first question is, how should the 911 community use this?
I think the biggest benefit for having a national database is that you have access to all of your surrounding areas. So in the ideal situation, a 911 entity's data is already in the National Address Database, and all of the surrounding areas are also there, and I think that's the biggest benefit.
Okay, our next question comes from Steve, and he's asking, how are PSAPs going to reconcile the trend of FEMA to use USNG and all the PSAPs using mostly decimal degrees?
We're not asking the authoritative source to provide us with that USNG. We included it in our minimum content guideline because FEMA asked for it, but we are calculating the USNG from the longitude and latitude that is provided by the authoritative source.
Okay. Megan would like to know, is this effort something NENA and APCO are also involved in?
NENA, I'm not familiar with the APCO acronym, but NENA was a participant in our summit last April, and everybody at the summit was given a chance to comment on the minimum content guideline as we were developing it. So my answer is they were involved, but it was I don't know off the top of my head the level of participation in the reviews.
And Megan's next question is this effort at all related to the National Emergency Address Database?
They were kind of diverging for a little bit, but now they are no longer diverging. Thanks to Lori's efforts, we've had a couple of calls over the last few weeks with FCC to make sure that the National Emergency Address Database and the National Address Database are aligned and benefit from each other.
Okay, Mark Fletcher would like to know, does the National Grid take into consideration Z or altitude?
I am not a national grid expert, so I don't know the answer to that.
Okay. And Helen is asking, can the participants get a copy of the database schema?
Yes, it's available on that second website on my last slide, next to last slide. But I can also, if I have access to a list of participants, I can send it out that way too.
Thank you. How do you envision the level of state participation in the NAD?
The states are key in that they're the aggregators of the authoritative data, and that's going to be quite the job in some cases. I know we've been working with the state of Ohio, who does compile their counties' addresses into a statewide data set, but there are many different schemas used at the county level, so their aggregation service is very critical to us, since we do not have the resources to do that aggregation. So the states are definitely the primary aggregators and will feed into the national address database.
Okay. Why have two national databases?
If you're referring to the National Address Database and the National Emergency Address Database, my understanding is that the goals are different, and that the National Emergency Address Database is more cell phone location based. So that will include a physical address of a residence or a business, and that's where we're trying to make sure that we have the same information in the two data sets. But the National Emergency Address Database goes beyond what the National Address Database does.
All right. How do you feel the refresh interval will be?
I think that's going to be dependent upon the state and the local providers. I know, I think it was the state of Virginia told us they update their, and correct me if I'm wrong, Fairfax County, but I think I heard that the state of Virginia updates on a quarterly basis. And what we would like to do is accept whatever update cycle the states and locals currently have, because that's less burden for the providers.
All right. Does your effort work to date have any planned interface with the National Emergency Address Database in that NENA and the carriers are working on?
Yes, we just started that interface. Lori and I have been meeting with quite a few people at FCC to make sure these things stay in lockstep.
We had one participant who joined a little bit late, so he is asking, is the NAD schema and documentation available for the county to try, which you mentioned, it's that link on the next to last slide, but he also wanted to know, how about the ETL tools?
Those will eventually be put up on a GitHub site that DOT is hosting, but we haven't gotten everything ready for that yet. But hopefully within the next week or two, a GitHub site will be available with every ETL that's been developed.
Okay. Doesn't Google Maps or MapQuest have this data?
They do, but it's not open and it's not public domain.
Okay. We also have a participant who's trying to get your link to work. But what we can do after we are done here, we can send that link out to all the participants today so they have that to easily access.
Okay.
Another question, when do you anticipate an app available, and how are you going to promote the process to develop the app?
It's through the America Competes Act, so it has to be advertised in the Federal Register, and we have been actively seeking partners in both private sector and the public sector to help spread the word. We have companies like Esri and Digital Globe that are sending the word out through their developer community. The U.S. Digital Services team under the White House is sending word out through the open source developer community, and we hope to generate as much publicity as possible once the Federal Register announcement hits the streets.
Thank you, Steve. We do have several other questions, but we do need to move on, so we will compile these questions and get answers and have them sent out to the participants after the webinar is complete.
All right, thank you.
You're welcome. Thank you. Lori, please go ahead and introduce the next speakers.
Okay, thank you so much, Sheila. So for the local perspective, on the topic of GIS, we have Mr. Thomas Conry and Judy Dildora, who are both with Fairfax County in Virginia. And they're going to tell us a little bit about a 2-year GIS effort in the National Capital Region and the data challenges and governance considerations for regional implementation. Ladies and gentlemen, the floor is yours.
Okay, thank you, Lori. This is Tom Conry speaking, and Judy Dildora will follow up here. And I guess good morning to everybody to the west, and good afternoon to folks in the east. I want to talk a little bit as manager about some of the lessons we've learned through our current generation CAD system and getting that going. Fairfax County went live with our current CAD system back in 2009, which Judy worked on, as well as me, and then several years before that. And some of that learning is really helping us move forward at an accelerated pace into next gen from our current gen. Within Fairfax County, this GIS office is within the Department of Information Technology, and we're a service back to Department of Public Safety Communication, which really owns CAD in the county, as well as police and fire, and all of them have GIS resources, and we work with them, but we also bring an enterprise perspective and enterprise data. And that's kind of given us a sense of what we need to do to succeed as that interaction, and we're building on that for next gen. And so if your organization is looking at next gen, and it's coming for all of us at some point, face it, there's significant changes coming, and the more you can kind of look over the horizon, prepare for those, lay a foundation for success, it will be to your benefit. Next Gen 911, as you probably know, is inherently regional. It's not a standalone solution. You know, when we originally started our new CAD system, we were kind of an isolated individual group. But what we had to do then was start dealing with data across our boundaries to deal with mutual and automatic aid, and started to have to deal early on, back before 2009, with our neighboring data to make it fit together for our center lines. And that structure is helping us move forward into next gen. It's also helping us be sustainable, and you really need to look at that for next gen. Next gen is going to be the standard until we have the next gen. So you really need to have your operations ready. You need to be looking at issues that help you go forward, because once the switch is thrown for a CAD system, then the pressure is really on, and changes become difficult, and time pressure is intense. So planning ahead, looking at interactions and how to manage that are really important. And really the way I talk about doing that is you want to look at governance. You know, we have governance in place as a result of our current generation CAD in the Northern Virginia area with our neighbors. We were able to then build on that regionally across not only Northern Virginia, but DC and Maryland, to start looking at what we have to do for next gen. And I encourage you to be looking at that as well. So within our organization, within the county, we're working across agencies with enterprise data. Our center line is available across the county, not just to public safety. It's a shared cost and a shared resource. We also have structure for ongoing relationship with our neighbors, which the Northern Virginia GIS managers put together for our current generation CAD, and then we're leveraging that for the region. The next slide will give you a sense of what we mean by the region. That's the National Capital Region, 22 jurisdictions, and actually we had to add 2, Stafford and Fauquier down in the southwest of Prince William County because of some of the Verizon selective router footprints. But this is the area that we're going to be moving to next gen. Not all at the same time, it's going to evolve. But fortunately, we've got some governance in place and ways to outreach. So we have the Metropolitan Washington Council of Government that we work with the GIS committees there, which I'm on, which Judy's working with. And then we have the Northern Virginia group that plugs into that. So the governance that we've got in place already is really helping us move forward to some of the challenges of next gen, which Judy's really been digging into. And Judy, the floor is yours.
Thanks, Tom. Good afternoon or good morning, everyone. My name is Judy Dildora. My part of the presentation, I want to discuss a little bit some of the background of our project and where we are currently with our NG911 project for the NCR region. The Northern Virginia Regional Centerline Group was created in 2009 to support a grant from the Virginia E911 Services Board to create a regional routable centerline model for CAD. In coordination with the state of Virginia, the Virginia Information Technologies Agency, and VGIN, the Virginia Geographic Information Network, for Fairfax, Loudoun, Prince William, and Arlington counties, and the city of Alexandria. This was a multi-year project which involved data modeling and testing and tool development and documentation. Today, the group continues to meet on a regular basis. We discuss current and future initiatives, project status, and other challenges facing GIS within the CAD and public safety arenas. As we move ahead into NG911, two of the most emphasized points from vendors and early adopters and those working on NG911 data preparation are the statements, "I wish we had started data cleanup earlier," or "I wish we had coordinated with our neighbors earlier." With the initiation of the NCR-SI project, the Centerline Group was leveraged, which allowed for more of a seamless transition and integration of the team and their work into our project. Communication was facilitated because we had already established the primary points of contact throughout the region, and we had regular communication. There was already a structure in place for project management because there were existing coordinator leads in place for the project. Participants knew who to contact with questions, issues, and comments. The Regional Centerline Project had also previously established some centerline standards that will be critical to our current project. I will discuss that a little bit more in the following slides. But what the Regional Centerline Project also did is it established a regional workflow where local data is provided to the state, who then consolidates the data to a regional centerline, then provides it back to the jurisdictions. While not at a point in our current project to really define our workflow, we at least can leverage our existing workflow and model from that when and if needed. One more thing coming out of the Regional Centerline Project is that we did develop an error reporting process so that stakeholders were able to submit errors to the Data Authority for review and resolution. While the NCR-SI project does include more participants, having the structure and process in place allowed for simpler integration for the additional participants from Virginia, which was helpful as the city of Falls Church and Fauquier and Stafford counties were added for our current SI project. Next slide, please. The Regional Centerline Group facilitated the creation of a regional data model which standardized both centerline geometry and attributes. Components of these will be necessary for the implementation of a regional NG911 dataset, and having these things in place allowed the project to get off the ground running with the data synchronization process. The boundary XY, what we call them the boundary XY, also known as snap 2 points, are agreed upon locations to snap the centerline at borders for maintenance purposes only. They do not reflect legal boundaries, but rather represent mutually agreed upon locations between the two participating jurisdictions. The before and after graphics show how the boundary XY points were implemented. The before graphic shows the Main Street centerline at the boundary between PSET A and PSET B. Previously, each maintained their centerline independently up to a location approximate to their border. I hope that's coming through okay on the slide. Note that there is a disconnect or a gap in Main Street. The after graphic shows the boundary XY point, represented by the red dot, as a location near the border and shows how the centerline on each side was snapped to that point. The end result is a continuous centerline crossing the border. Both jurisdictions agree to maintain their respective centerlines to that boundary XY point. Next slide, please. The Regional Centerline Project did also establish some geometry standards for how divided roadways and elevated crossings such as overpasses were represented. This was critical in our data model development because the ultimate purpose of that centerline was to support vehicular routing in CAD. and as a result, the regional center line established that divided roadways are represented with dual center lines. And this becomes relevant to our current project because of the edge matching purposes at the borders and resolving any conflicts between jurisdictions that may be using single versus dual center lines. Ultimately, the Regional Centerline Project established some initial data maintenance agreements across the region. The Boundary XY initiative defined GIS centerline maintenance responsibilities for streets that may cross or straddle the border and have associated addresses in more than one jurisdiction while creating a seamless and edge-matched centerline. Additionally, the project did establish a regular schedule with the state where each jurisdiction provides their centerline on a quarterly basis to the state, who then merges the centerline into a regional data set while updating the statewide centerline and providing it back down to Northern Virginia for use in their production data. Currently, that centerline is being used to update data to support local 911 systems. Next slide, please. The NCRSI project kicked off in early 2016, and at this point, we are in the very early phases of the data synchronization process. Each jurisdiction's source data, which includes address points and center lines, have been provided to be analyzed against service provider data, such as the MSAG and ALI databases, to ensure at a minimum that the valid MSAG and ALI records are contained within the GIS centerline and address point data where available. The goal of the task is really to ensure that no data is lost when moving from a tabular-based call routing to a GIS-based call routing system. As such, MSAG and ALI address records must be represented in the GIS data. The checks being performed are comparing such things as street names, address ranges, community values, and ESN values between the GIS and the server provider tables. It is a multi-step process that ensures if there is an MSAG or ALI record, there must be an associated GIS record. If the MSAG or ALI record has a record for 123 Main Street, Whoville, then the GIS must have an address point for 123 Main Street, Whoville, if address points are available. If address points are not available, then 123 Main Street, Whoville must be found in a centerline address range. Note that if address points are available, there must be both an address point and centerline range for that 123 Main Street, Whoville address. Any instance where there is a discrepancy between the MSAG and ALI databases, the records are being flagged, and we must review them between the PSET and GIS folks to determine why there is a discrepancy and how that discrepancy can be resolved. This process requires coordination across internal agencies such as GIS and PSET folks, in addition to external coordination with the service provider for the MSAG and ALI related issues and outreach to neighboring jurisdictions to resolve any discrepancies at the borders that may require resolution between the adjacent PSETs. The error resolution process for us was also a very multi-step process. For us, the first pass was in the county GIS office. The discrepancies were typically validated against the county address database to verify that the address or the street name was indeed a valid county address. Additionally, any street name discrepancies were validated in this manner to ensure that the street name was spelled properly. Community discrepancies were validated against the GIS zip code layer, since both the community and MSAG and GIS represents the general postal area designations. After this initial review, the discrepancy was then passed on to our PSET GIS staff, who would then validate again and make the final determination on the resolution. So if the resolution required a change to the service provider data, the PSET would follow through on that. If the resolution required a change to the GIS data, the discrepancy was then passed back to the GIS office for follow-up. So there was a lot of communication and there was a lot of back and forth just in the review of the initial errors alone. So what types of things were we seeing from this initial analysis? At this point, many of the issues were due to duplicate records in MSAG. It appears that the MSAG would often have both the incorrect and correct record, essentially duplicating the record. In this case, the resolution was easy. We just deleted the duplicate incorrect record. A significant number of discrepancies were due to differences in street name representations between the MSAG and GIS. There were differences in the way numeric street names were handled. Sometimes the number was fully spelled out versus the actual number in the street name. There were differences in the way punctuation was represented with the apostrophes and dashes in street names. And these sorts of discrepancies were relatively straightforward to resolve. We basically kept the record which matched the official county street name. However, there were also discrepancies that could not be immediately resolved because they will require collaboration with our neighbors. These discrepancies concern addresses and center lines of the borders which cannot be resolved by one jurisdiction or another. We put these on hold until we can actually get through all of the synchronization checks, because we know once we get through all these checks, we will have more issues. And just to streamline the meeting process, we've just flagged these for now. When that time comes, we will plan on one-on-one meetings with our neighboring jurisdictions to review these issues and plan on how to handle those. Going ahead. Next slide, please. Ultimately, these issues and discrepancies that have been put on hold will serve as discussion points during our one-on-one meetings with our neighbors to take a look at that data crossing our borders and determine how best to handle these from a call routing and PSET perspective. So you might ask, like, why do these discrepancies even require collaboration with our neighbors? Ultimately, these issues will serve as discussion points to refine the PSET boundary. And why is this important? The primary use of the GIS PSET boundary file in NG911 is to route calls. It defines the coverage area for a given 911 authority. And in today's environment, a call is routed by querying our service provider data to determine which PSET should receive the call. In the NG911 environment, a call will be routed by locating the caller, then querying the PSET boundary GIS file to determine which PSET should receive the call. As a result, there must not be any gaps or overlaps in these coverage areas as this could potentially delay the call routing process. With this in mind, it becomes critical to collaborate with our neighboring PSETs during the development, refinement, and maintenance of that PSET boundary layer. Ultimately, this layer should be developed with the PSET business requirements in mind and with GIS in a supporting role of this. Next slide, please. The starting point will be to determine the best source for the preliminary PSET boundary layer. For our NCR project on the Virginia side, some jurisdictions already had a PSET boundary layer, some did not. But because everyone developed their PSET boundary to fill their own needs, piecing together the individual boundaries where they did exist into a regional PSET boundary would require significant work up front to create an edge match layer. We discovered a lot of geometry issues along the borders, such as those gaps and overlaps. A PSET boundary for NG911 must be coincident along the borders and not have gaps, which would be an area of no coverage, and not have overlaps, which would be an area of overlapping coverage, resulting in possible routing to the incorrect PSET. We also knew that this would be only a preliminary layer, and as we progress through the project, we would need to meet one-on-one to review and refine the layer. So fortunately, in Northern Virginia, the PSET boundaries also follow closely our jurisdictional boundaries. Therefore, we chose a data source that offered a continuous edge match layer for the region that would require minimal initial work. So our data came from VGen's statewide county layer, which was originally derived from the census data, but supplemented and modified with local jurisdiction data. We did end up supplementing this a little bit more to add in some of the federal properties, such as military bases and the airports. And at this point, this will serve as our initial preliminary PSET layer. Our next step for this is to refine this in collaboration with our neighboring PSETs. And what does this mean? As we are receiving back the results for our data synchronization analysis, like I mentioned earlier, we are flagging those records that cannot be resolved at just a single PSET level because it requires mutual agreement for resolution. We will need to sit down one-on-one with our neighboring PSETs, review those discrepancy records, review the MSAG and ALI records, review the GIS data, and make a decision on how to modify the PSET boundary accordingly. Will the PSET boundary be refined to draw around parcels? Maybe. Will the PSET boundary be refined to draw around certain streets? Again, maybe. There is no one solution that's going to fit all. This will be very much a case-by-case basis with the final determination driven by the PSET needs. While the PSET boundary development will be very much a coordination between adjacent PSETs, the long-term maintenance of it will also need to be a mutual effort. If PSET A makes a change to their PSET boundary, then it must be coordinated with PSET B or risk the possibility of reintroducing those gaps and overlaps, which could potentially lead to a delay in emergency response. Next slide, please. So in terms of the project, what are our next steps? We plan to continue on with the data synchronization process. At this point, we are still very early in the stages of this. Because of the number of participants in this project and the potential staff time involved to review and resolve the issues, the stage has the potential to be very time-consuming. What should you expect from your project as you move ahead with NG 911? There will be impacts on your data. Your MSAG and ALI will require edits. Your GIS data will also require edits. You will be creating new layers to support the NG 911 implementation, and the amount and level of effort will depend upon the results of the analysis and what data currently exists. As we progress through the data synchronization phase, there will be discrepancies that cannot be resolved at an individual PSET level, and we must work with our neighboring PSETs to review and resolve these and refine the PSET boundary file to reflect those decisions and agreements. As we transition to a more regional level of 911 data management, we'll need to transition our mindset to a more regional focus when it comes to data maintenance. In the past, the norm has typically been for each jurisdiction to maintain their data, end of story. Under NG 911, it will be critical to understand how edits to our data at our borders may impact the regional NG 911 model, and more specifically, the impact on the PSET boundary file and how calls will be routed. There will be a need to coordinate and collaborate and a lot more agreement moving ahead. The steps and the tasks listed above are going to be a continuous cycle, and how this is all going to come together in the end with our project is still to be determined. Perhaps we can provide another update in a few months when we get a little further along in the project. But at this point, I've provided all the information that I have, or if anyone has any questions, you can contact Tom or I personally, and we can definitely give you some guidance on what we have learned so far. Thank you.
Thank you very much, Mr. Conry and Ms. Dildora. Unfortunately, we do not have time for questions right now. We apologize for the technical issues we had, but we will get the questions that were posted, gather them together, and send out email responses. Lori, did you have any closing remarks for today?
No, clearly from the number of questions just from the first round, there's a lot of interest in the topic. So thanks to all of you for hanging in there. I apologize again for the technical difficulties, and thank you so much to Steve and Tom and Judy. We really appreciate your time. Thanks.
Thank you all.
This concludes today's webinar. We appreciate everyone's participation. An archived version of today's webinar will be available on 911.gov soon. The next seminar is scheduled for Tuesday, October 11th at 12 noon Eastern Time. We hope you will be able to join us. Thank you and have a great day.